Hi, so for today we are going to talk about differential equations, calculator techniques. I know you've been waiting for this video, but here it is. We're going to solve DE using calculator techniques. And we have a new emulator for today's video. Thank you so much, Karst, for sending me a copy of your virtual emulator calculator. And also, I have received a calculator from them. So, guys, if ever you are wondering if this is allowed in the PRC, it's allowed. Okay, so from now on, from my calculator techniques, I'm going to use this cars so that you don't have to worry if the calculator that you are using, okay, that we are using in this video is allowed in the PRC. Okay, so let's get started. Okay, for number one, find the differential equation of the family of the curves by given by y equals mx squared, where m being arbitrary. So the thing is, in solving differential equations in terms of calculator techniques, we need to somehow have an understanding that we should substitute certain values for our variables, especially to the arbitrary constant. Okay. So what I'm going to do here is that I'm going to let I'm going to let any arbitrary constant, in this case that is the m. Okay, that's the arbitrary constant here. So you have m equals to 1, and I'm going to get the derivative of the dependent or the independent variable. The independent variable is x, so I'm going to get the dy all over dx of x squared at x equals 0.1. So whenever we try to solve DE, we should let the arbitrary constant equal to 1, and we should let the derivative of the or the independent variable x equal to 0.1. So what we are going to do is first, all right? So I'm going to get first the derivative, okay? So I'm going to get the derivative. So get the derivative using your calculator. Shift, you have the all over dx of alpha x squared, where x equals 0.1. Okay, so I'm going first to solve this value. All right. So if I solve this value, I have an answer of 0.2, which I will store it to shift store to m. Okay? So that m, take note, that variable m is the slope. Okay? It reminds us of the first derivative. So you can also store it to any other variables, but for me, we are going to store it for m for us to be reminded that this is the uh, uh, y prime, the result of the y prime. All right. So the very second thing that we're going to do is we're going to go to the choices, okay? And on the choices, we are going to make the equation, okay, equal to 1. So what I'm going to do here, for choice A, I have y prime all over x squared y equals 1. So if I divide both sides by x squared y, okay, that would be the other side of the equation will be equal to 1. So we're going to do that for all of the choices. Okay, so what are we going to do is we're going to calculate y prime all over x squared y in our calculator. Okay, so and if our calculator basically we're just simply going to enter, okay, the y prime is the one that we have for our value, value for the m, right? So we're going to call m, okay, we're going to call m, that is our y prime. And we have x squared, okay? Going to call the x squared. Oops, we still have y, okay? So how do we solve y? We're going to solve simply y as the x squared, okay, at x equals 0.1. So what we are going to do is we just calc, okay, let me just get this first. I'm just going to calc x squared by inputting a value of x which is still the 0.1. And this value I will store to shift store to y. Okay? So again, I'm going to calculate this. Calculate x equals 0.1. So I'm going to shift store this to y. So whenever I call the value of y, that is 1 all over 100. And we have alpha m. This is the result of the differentiation of x squared at x equals 0.1. And again, our y, that is the result when we just substitute x squared at x 0.1. So that will be your y. So if I'm going to input this in our calculator, so you have y prime, that is my derivative at x at 0.1, m all over x squared, okay? And then I'm going to call y. I'm going to calculate this, okay? And if it is equal to 1, then this is the right answer. So cut m equals 0.2, that's what we get a while ago. X is 0.1, that's good. And y is what we have stored in the y a while ago. Okay, the result when we just substitute x 0.1 to the x squared. So if it's going to be 1, it's the answer. So letter A is not the answer. So definitely that's not the answer. Let's move on to letter B. Okay, for letter B, if I'm going to divide whole side of the equation by 2x y prime, that should be equal to 1. Okay, and now what I'm going to do is still write this again in terms of my variables. So I have y, alpha y, and I have 2 alpha x, and then the y prime, of course, is the m. That is the result of the first derivative at x equals 0.1. So you have to get m. Okay, so our calculator input looks like this. It's 1/4. It's still not equal to 1, so that's not the answer. Okay, so let's go now. How about letter D first? We try letter D. So you have 2y all over x y prime equals 1. Okay, so we just, again, let the right side of the equation be equal to 1 by dividing both sides by x y prime. So you have 2y, and then we have x, and then y prime, of which y prime is m. So if that is equal to 1, then definitely that's the answer. So the answer for our problem number 1 would be letter D. Alright, so a little recap of what we did a while ago. Again, first, we let the constant equal to 1. Whatever the constant in the equation should be equal to 1. Okay, number 2, since we have x squared here for our independent variable, we just calculated x squared at x 0.1 and we stored that into the y. And lastly, we also have dy all over dx where we get the derivative of this x squared at x 0.1, and that value we stored at m. And that denotes dy prime. So, and going on to the choices, we just simply divide, okay, or we just simply simplify the choices. In the right side, equal to 1. And on the left side, that is what we are going to put on the calculator. And after putting it, if the result is 1, then definitely that's the answer. Okay? So problem number 2, find the differential equation of y equals 4 plus c e raised to 3x. So again, if we have an arbitrary constant, that should be equal to 1. Okay? So that should be equal to 1. And x should be equal to 0.1. So first, we get the y value. We have 4 plus, since c is 1, so we have simply 1 here, e raised to 3x. So we get that in our calculator to get y. So we have 4 plus alpha e, okay, raised to 3 alpha x. So calc, then he's asking for a value 0.1. So we just shift store that into y because that is the value of our y. Okay. So next, we have to get, okay, the value for the derivative. The derivative of what? Shift derivative here. We have the derivative of 4 plus c e raised to 3x with c equals 1. So the function reduces just like this. So we have 4 plus alpha e raised to 3 alpha x. And then that is x equals 0.1. And that value, we're going to shift store at m, reminding that that is y prime. Okay, now going to the choices. Okay, we now have letter A. So we are going to divide this both sides by 12. So that we have y prime minus 2y all over 12 equals 1. So that is for our letter A. Let's try if that will be equal to 1. Okay, so we have stored already our values. So we have y prime, that's recalling m, minus 2 alpha y all over 12, and then calculate it, equals. So it's not equal to 1, so that's not the answer. How about for letter B? We have y prime plus 4y equals 12 equals 1, or over 12 equals 1. Sorry. So I just have to simply change this by plus 4, okay, and divided by 12. So y prime plus 4y all over 12. Will it be equal to 1? No, it's not. So this is not the answer. Letter A and letter B is not the answer. How about letter C? If we do letter C, okay, we just simply write this as y prime minus 3y all over negative 12 equals to 1. So if this is equals to 1, then definitely that's the answer. So I'm just going to rewrite this. Y prime, okay, minus, that's m for our y prime again, and then 3 alpha y all over negative 12. So don't forget the negative sign. So if we wish to calculate this, giving this value that we have stored, m, y, and x, okay, my, okay, I'm sorry, my, so that will be, the answer is 1. So definitely the answer is C. It equates to 1, so definitely that's the answer. All right. So for problem number 3, we have two arbitrary constants. All right. So for this one, we have to let c sub 1 and c sub 2 equals to 1 again, because that's the arbitrary constant. And the thing here is we have two arbitrary constants, so we need to have two derivatives. As you can see in the choices, second derivative, I mean, as you can see in the choices, we have y double prime and y prime. So it means we need to get the double or second derivative of this so that we can get the answer for this. So first of all, we need to let x equals 0.1 again. So first, in our calculator, we're going to solve the y. We have 1 plus e raised to 3x, okay, at x equals 0.1. Then we're going to shift store this in y. So let's do that. If we do that, we have 1 plus e, or alpha e, raised to 3x alpha x. Okay, calc for 0.1, that would be shift stored into y. Okay, and next is, of course, we are going to get the first derivative and the second derivative. So for the first derivative, we know that that would be y prime, okay, and then getting the derivative of 1 plus e raised to 3x at x equals 0.1. And that we will store again to m. Okay, so we're going to store that to m. So again, we try 1 plus alpha e raised to 3x. Then we have 0.1. Okay, so we have shift store, okay, m. Okay, so we have stored that already to m. Okay, so storing that to our m would give us the m. 4.049576423. Okay, just recalling our m. So again, if we're going to get the second derivative, okay, remember in our calculator techniques, the formula a minus m all over, we have delta x. So in our calculator technique video, we are taught how we are going to get the second derivative by calculator techniques. So for those don't know it yet, we have y2 minus y sub 1, okay, prime all over delta x. So how do we get that? Okay, simply we already have the m. What we have now, we are going to solve is the a. Okay, so we have a. The a is simply the same function as what we have inputted a while ago. And the x is 0.1 also, but we're going to add the delta x. So we are going to have plus delta x, which means a very, very small amount. So that small amount would be 1 times 10 raised to negative 5. Okay? That delta x equals to 1 times 10. That delta x equals to 1 times 10 raised to negative 5. Okay? So you're going to add that to 0.1 and get the derivative. So if I'm getting, you have shift store, we're going to store it at a. Okay? So in order to get the derivative, we have now the formula. Second derivative, we have a minus m all over the delta x, of which the delta x is still 1 times 10 raised to negative 5. So we have calling a minus m all over the delta x, 1 times 10 raised to negative 5. So this would be your second derivative. And your second derivative, you're going to shift store it to d. Okay, shift store d. So again, we have to shift store it to d. Okay, so meaning, we have c1, c2 equals 1. We have x equals 0.1. We have the first derivative equals to m. And we have the second derivative equals to d. Okay, so now time to go with the choices. So for the first choice, we have y double prime plus 3y prime. Okay, so equals to 0. So if it is 0 on the right side, so we just have to simplify this. So you have y double prime equals negative 3y prime. And of course, dividing both sides by negative 3y prime. So you have y double prime all over negative 3y prime equals 1. So that's how you arrange it. Okay? So in order for the right side of the equation to become 1. So when you try this in your calculator, so you have y double prime, that's alpha d, all over negative 3. Okay? And then alpha m because of y prime. So that's how you type it. If this is equal to 1, okay, that's the correct answer. So this is negative 1. Okay? So negative 1 is not equal to 1. So moving on to the choices. So you have letter B again. So you have y double prime plus y prime equals 0. So I just transpose y prime so that it becomes negative y prime. So yeah, I have y double prime all over negative y prime should be equal to 1. So which shall we try that for letter B? So if I try that, that would be y double prime, that would be d all over negative m, which is the y prime. So negative 3, that's not the answer. Okay, moving on forward to letter C. Let's go to letter C. So for letter C, you have y double prime minus 3y prime equals 0. So we have y double prime equals 3y prime. Divide both sides by 3y prime. So you have y double prime all over 3y prime equal to 1. So let's try that. Y double prime. So I have the d already on the calculator. So you have 3y prime, which means m. Okay, if this is equal to 1, then that's the answer. All right. So this is approximately equal to 1. Okay? After rounding off with the decimals. So the reason for this is that we have some values here is that we are using an approximation method. So technically, this is approximately equal to 1. So the answer here should be letter C. So if we are not, if we want to just check, okay, we have now the answer as letter C. If we just want to check what will be the value of D, okay, just to make sure that that should not be equal to 1, we'll try it also. So we have y double prime equals 2y prime. So we have y double prime all over 2y prime equals 1. So that's what we are going to do here. So we have y double prime, that's I'm sorry, that's D, okay, all over 2, okay, m, okay, and the result is 1.5. So clearly the result here should be what? It should be letter C. All right, that is for problem number 3. How about for problem number 4? Okay, so the same scenario we are going to do. First of all, we are going to equate C1 and C2 equals 1. So we have x equals 0.1. And of course, y, we're going to evaluate that, okay, as e raised to x plus e raised to negative x, because the value of C1 and C2 is 1. Okay, so at x equals 0.1. So shall we try again? Okay, so get the alpha e raised to alpha x, okay, plus e raised to negative x. So calc, for 0.1, we are going to shift store that to y. Okay, that's our y. So again, we have two arbitrary constants. So we're going to solve the second derivative. So we have e raised to x again. And then plus e raised to negative x. Okay. So x is 0.1. Alright. So for the first derivative. So you have shift store m. For the second derivative, again, we're going to get the replay for this. So for this a, we're going to add 1 times 10 raised to negative 5. And this value we shift store to a. And again, our formula for the second derivative would be a minus m all over 1 times 10 raised to negative 5, or the delta x. So that value y double prime should be stored at D. So let's try. So you now have alpha a minus m all over 1 times 10 raised to negative 5. So this will be our second derivative, which will be stored to D. Okay? So again, going to the choices, once again, okay, so we have for letter A, we have y double prime minus y prime plus y equals 0. So I have y double prime minus y prime equals negative y. So if I divide that by negative y both sides, I have equals 1 here. So I'll try to do our calculator. It's so nice that our calculator view is big. So you have second derivative, which is D, minus first derivative, that is m, all over negative alpha y. If this is equal to 1, that's the answer. So it's not. It's negative 0.9. So that's not the answer. For letter B, we have y double prime minus y equals 0. So that would be y double prime equals y. Y double prime all over y equals 1. Alright. So we now have y double prime is D, or the second derivative, all over alpha y. Okay? This is equal to 1. That's the answer. Oops. Okay? This is approximately equal to 1. Okay. So I need to stop calculating and I need to conclude that letter B should be the answer for this problem. Alright? So, last problem for this video. Don't worry, we'll be having many part, okay, of differential equation video. So, keep on tuning in to our channel. So, for problem 5, we have to find the differential equation of y equals c sub 1 sine 2x, c sub 2 cosine 2x. So, note that we already have trig functions. If we have trig functions, okay, if trig functions is involved, take note that we should be in radian mode. Okay? We should be in radian mode. Okay. So, I'm going to convert my calculator to mode, shift mode to radian 4. Okay? So, that is safe because we are dealing with trigonometric functions. Again, I'm going to let c sub 1, c sub 2 equals to 1. Okay? Still x equals 0.1. I'm going to get y, of course, no? So we have sine 2x plus cosine 2x at x equals 0.1. Okay? So I have sine 2 times 0.1. Okay? And then plus cosine times 2 times cosine of 2 times 0.1. So that will be my y. Shift store y. Okay, automatically. So since we have two arbitrary constants, again, we need to get the second derivative. Okay? So the second derivative. So first derivative, I'm going to get, so you have sine of 2 alpha x. Okay? Plus we have cosine of 2 alpha x. Okay. X 0.1. So this will be the result of my m, which is the first derivative. Now to get a, simply replay, and I'm going to add 1 times 10 raised to negative 5. Okay. And that would be the value I will shift store to a. Okay. And again, to get the second derivative, I have alpha a minus m all over 1 times 10 raised to negative 5. The value of this, I'm going to store to d, which is the second derivative. Shift store d. Now, going on to the choices, I now have the complete. So, I have y prime equals m, and I have y double prime equals d. Oops, y double prime equals d. So, going to the choices, I have y double prime plus 4y equals 0. So I have y double prime equals negative 4y. Y double prime all over negative 4y equals 1. So let's try that. So if I try that, you have y double prime. That's the second derivative d all over a negative 4y. Oops, this is really approximately equal to 1. Okay? So we are just we are just lucky that the very first question that we substituted approximates to 1. Okay? And that we conclude that should be the answer for this problem. Alright, so I hope you learned from this something from this video. Thank you so much once again for tuning in, and shout out to all of our subscribers who are continually watching. I cannot thank you enough, and thank you so much for supporting our channel. So again, this is Jei Abat. See you again on the next video.